as you've just heard, my name is Bridget. I work for a small company here in Wellington that you may have heard of, Datacom. I'm in our software business as a consultant in our application performance management team. Now, the majority of people that I tell that to have absolutely no idea what that involves. In fact, I was putting together this presentation and making my boyfriend listen to it as practice. And he turned around at the end and was like, is that actually what you do? It's like, that kind of makes sense now. I've been dating him longer than I've been doing this job, so clearly I don't explain it very well. I think I'm pretty lucky though. I have a pretty cool job. I get to work with a whole lot of different teams, both technical and business facing, helping them incorporate a performance focus into the way that they currently write their code and the way that they operate. One of the most exciting parts of my job, in my opinion, is that I get to do a whole lot of firefighting in different production environments with different technology types. Somehow, over the last 2.5 years, my team have made ourselves the people that you call at like 9:30 on a Friday night when things are just so bad that you have really no other options. And I don't know how that happened, but apparently it has. I've been doing this for a while, so we've started to notice quite a lot of patterns in the things that we get called in to look at. And most of them, I'm pretty convinced, could have been detected either in dev or test, anyway, long before I had to get involved with them in production. So sit back, let me tell you a story about an issue I worked on last year and how it could have easily been prevented in dev or test if we had been looking for it. So the story starts a while ago, start of last year, 2015. I used to sit next to this team at work. They're an operations team. I had basically no idea what they did, but they were the sort of team you'd read about in books, and not the good sort of books. They seem to have a different disaster every single day. So we got to know, sitting next to them for a while, how bad their disasters were based on the random guys that would turn up in suits at different points of the day and stare over people's computers, kind of making suggestions as they went. General consensus from everyone in my team and everyone who we sat next to is we were 1,023% convinced we absolutely never wanted to be in that ops team. Jump forward 6 months, they'd gone. It was a whole lot calmer on our floor. It's Friday night, I'm sitting at home on my living room looking forward to a nice relaxing weekend, and I get a phone call from my boss. Now, something that I've learned is that when my boss rings me on a Friday night, at any point in time after 4:30, you can write Friday off, you can usually write Saturday off, and you can probably forget about Sunday because it's going to be Monday before you know it. Answering the phone, I heard sort of what I've come to expect from these sorts of calls. Application crisis, performance issues, they've got a massive war room. Do we think we'd be able to do anything about it at the last minute? So I'm a sucker, and so I get really excited. I love a good unsolvable problem, so I'm one of the few people that you would ring in this situation who goes, great, tell me about it. When can I start working on it? 10 minutes later, I'm sitting on my living room floor with my laptop on a conference call with what seems like every man and his dog. Now, our number one activity when we get rung like this on a Friday night is always to do a tool drop. So every single time this has happened, we've been looking at application issues with infrastructure monitoring tools like Nagios or SCOM. And sometimes you can do that, and all the more power to you if you can. But if you ring me on a Friday night and you want me to look at an application that I don't know and I don't understand, you're going to get an APM tool pretty quickly. We're pretty lucky in that from the outset we've been partnered with Dynatrace here in Wellington, so I get to use their cool tools, and not that I'm biased, but I do think they're pretty sweet. So 10 minutes later, I get off this conference call and they've delivered. I won't bore you with all the details, but we get the whole environment for the next few hours to basically do whatever we want. So it's 2 a.m, I'm in bed, we've done a full tool deployment, looking forward to getting up the next day and getting started on this problem. So I'm up early the next morning in the office by 8 a.m. Lo and behold, the team that I'm working with is that poor ops team that I used to sit next to. Seems like things hadn't really got that much better for them, and their problems had all of a sudden sort of come to a head. Now, I spent the morning sitting down with a whole lot of different people. Talked to their developers, talked to their architects, talked to their ops guys. At this point, they were all pretty convinced it was a memory leak. They'd been looking for it for 2 weeks and they hadn't been able to find it, they hadn't been able to figure out where it was happening or what was causing it at all. Now, this should have rung alarm bells for me. If someone rings you to fix something and they tell you exactly what it is, but they can't give you any details whatsoever as to why it's happening or how to fix it, I'd be very suspicious that they actually know what's going on. That's okay though. I spent Saturday watching the completely normal behaviour of their application, and I should point out it's quiet business day for their clients, so much less users than usual. So everything looks good. We spend basically the whole day doing memory analysis trending and looking at the way that objects are changing on their heap, trying to figure out and find this elusive memory leak that they're pretty convinced that they're looking for. At the end of the day, I've got some good leads. I'm pretty convinced I know what's happening. We go home, looking forward to Monday to prove myself right, basically. So I spend Sunday doing a bit of light reading. I go back to this book, Java Enterprise Performance, which is kind of my go-to in this sort of situation. It covers a whole lot of stuff around garbage collection, memory behavior, the way that complex Java apps work under pressure, common issues, how to fix them, that sort of thing. So, Monday morning rolls around. I'm easily one of the first people in the office again. I'm about an hour into my day, sitting, sort of watching what their app's doing, and all of a sudden it happens. It starts to crash, and it starts to crash bad. We go from about a 0.98 AppDex value to about a 0.79 shockingly quickly. And it's going down. It's going down really fast. There is no comeback from this. There's absolutely nothing I can do about it. So I grab my phone and I make a call to their ops manager. The app's crashing. In my experience, there's only 2 ways that people react to being rung by a complete stranger to tell them that their app is going down. The first way is to say, thanks for telling me, what can you see and how can I fix it? The second way is to completely not believe you, which is fine. They went with the second way in this case. Well, that's all good, I'm used to that. But it was okay, because the guy I spoke to on the phone had 3 really good reasons not to believe me. The first, the app couldn't possibly be crashing because all of their Nagios dashboards were completely green. Cool. The second, Jim, one of the guys in their ops team, had actually just logged into the app, and it looked pretty fine to him, you know, it seemed good. And third, and my kind of personal favorite, is the app can't possibly be crashing because no one has rung us yet to complain. Cool. What I've learned when you get told this is there is very little you can say to these people to convince them that you are right. So I did what I usually do. I watched, I took notes, I tried to figure out what was happening, and then I went downstairs to the coffee shop in our building and I ordered myself a coffee. I knew it was going to be a very, very long day at this point. Unsurprisingly, I just pick my coffee up, I take my first sip, and I get a text message from my boss that just says, "You'd better get over here." Cool. So at this point, I should probably stop for a second and just tell you a little bit about the technology stack that we're looking at. So as you may have guessed, it's a Java application running in a fully Linux environment. It's been set up using JBoss, running across multiple servers with multiple JVMs running on each server. It is set up to look like a cluster, but there is no clustering behavior set up at all. So that's cool. There is a couple of Oracle databases. They've got an active MQ instance. They've got a MuleSoft ESB server, and they are using HornetQ and a whole lot of other stuff. It's fair to say there's quite a lot going on. Unsurprisingly, I get back upstairs, everyone's kind of freaking out. They're on the verge of making the call with the client to restart the entire production environment. So every single server, which takes about an hour and a half, unsurprisingly, and means that the app is not going to be accessible by anyone to do their job until about like 11 o'clock in the morning. So I sit down with a few of the ops guys and we have a look at some of their dashboards. They're mostly Nagios. They're all still green at this point. I start sort of showing them what I'm seeing in the APM tool that we're looking at, and we managed to isolate it fairly quickly to an out-of-memory error occurring on one of the JVMs. Coupled with the fact that that JVM is now frantically sitting at 100% CPU usage as it tries to garbage collect and can't. So they didn't quite believe me yet at this point, but they were pretty keen to jump on anything that didn't involve restarting everything. So I got them to give it a try. We restart this one JVM, the application comes roaring back to life, and everyone is kind of stoked. So we're kind of here at this point. We have no idea what's causing it, but we can mitigate the symptoms early enough that the users of the application can't tell that we're freaking out. This is always a good place to be when you're looking at production environments. I mean, if the users can't tell that there's problems, they don't really care that you as the ops team are running around freaking out trying to fix everything. So everything's looking good. We're now in a pretty sweet position to start actually looking at what's going on with the code and what's causing all these problems. So spend the rest of the day looking at it, don't really get anywhere. The next morning I come into work and I overhear a conversation from one of the developers that leads us to look at one of the data import processes running in the system. It's kind of an off-the-cuff remark, but it seems good enough that we go with it. Zooming in to look at this particular transaction, I see a rather astonishing number that I have never been able to replicate with any other client. 2.3 million database queries every 30 minutes. Now, I'm sure there are applications where that number makes sense. Maybe. But this client has 260 concurrent users in any half-hour period, max. So at this point I'm going, this doesn't really add up. We start to look into it and we see that this number of database queries runs like this, regardless of whether there's actually anyone logged in to the front end, which is not a good sign. So at this point, you might be thinking, hey Bridget, this is a really great story, perhaps, but how does it really relate to you? What's the point of me standing up here and telling you about this? I would say, I'm pleased you asked. Along with so many other jobs at the moment, one of the kind of unspoken rules of mine is to be so good at it that the teams that I work with don't need me anymore. And that comes from teaching people how to sort of detect and look for these sort of problems in their dev and test environments before they get into production and break basically everything. So, yeah. 80% of the things that we see could easily be detected in dev or test if you were actually looking for them and you knew how to look for them. So, yeah. Next question is why? Why is this piece of code behaving like that? And so let's jump back a little bit in the life cycle of this piece of code and have a look at development. So the project that we're looking at kicked off a couple of years ago. One of the developers one day probably got assigned a task. I'm not a developer, so I don't know how this works, but probably got assigned a task to write a feature to import a CSV file from another system to update the database. It's pretty easy. They would have sat down, they would have written a little bit of code, picked the CSV file up off the mule box, send it via AMQ messages to the backend application server, and then use the Hibernate framework to make all of the updates. It's all in all, it's a pretty elegant solution, and it looks quite nice at this point. It's probably not that much code required, and it probably runs really fast on the developer's laptop. So we're all good. The code gets checked in, passes all its unit tests, and is quickly moved through into the test phase. What they don't see, because they didn't know to look for it, is how this piece of code actually behaves, even on the developer's PC. One call to the mule box generates 12 messages through the AMQ box to the backend application server. So one message for every single line in the file. We then have the application server making queries off to the database. So you'll see here on the developer's PC, it runs about 102 database queries. Now, if you're me, you look at that and you go, that doesn't make sense. The application at the maximum should be running 2 database queries per call. So it should be doing a select to the database to select the information that it needs to update. And then it needs to do an update to the database to update the information that it needs to update. So this should be a fairly good sign at this point that things aren't quite happening how we thought they were. But you missed that, that's all good. It's not too late, we move things into test. So someone goes off, the piece of code's committed, it's picked up by your fancy test build framework that builds it, deploys it to a whole lot of test environments, runs a sweet test automation framework across it, and you get some test results. And they still look pretty good. All of the tests are passing, the things that we expect to happen are happening. Great, everyone's kind of happy at this point. But we take a little bit of a closer look at some of the key architectural metrics for what this code is actually doing, and we start to see something a little bit more scary. So you'll see the table on the right. We have, for each of the test runs, the number of AMQ messages, which is the number of lines in the CSV file. We have the number of database queries, which is the total number of database queries that were run by that process in that test. And also the average number of rows returned from the database for any given query in that test. Now, what you should notice looking at that is that the numbers grow when the AMQ messages are the same, and then we add a couple more AMQ messages, a couple more lines in the file. The number of database queries grows kind of dramatically, as does the number of average rows returned from the database. So, this should, at this point you should probably be a little bit suspicious. I like numbers, so I see things like that and go, that doesn't make any sense at all. Can you please tell me what's going on and why it has changed? You probably should, at this point, jump into a different tool set. So there are so many products on the market at the moment that will actually show you the execution path of all of your code. So from the first request that hits your system, every single method that is executed after that, as well as your database statements in context and response times for all of these things, as well as like parameters and stuff like that if you want to look at that. You can get everything basically from open source and free through to as expensive as you want to pay for, basically. And that should give you more than enough information in either dev or test to notice something like this, but also look at what's happening and figure out why your number of database queries is going up significantly when you haven't made any code changes to this piece of code. Because if you become suspicious about something in dev or test, you absolutely should investigate it. Because all of the clever automation and all of the pipelines and all of the really cool DevOps stuff that we like isn't probably going to help you when these sorts of problems get to your production environment and just cause chaos for everyone involved. Sure, it means that at that point you might be able to release a fix much faster than a team that doesn't have all of the automation and tooling in place. But detecting these sorts of things in dev or test is always a whole lot simpler than trying to figure them out and fix them once they've hit production. Because I know that unlike me, most people don't like being rung at 3 o'clock in the morning because the database has gone down due to load. And they also really don't like having the users of their application ring them up and complain about how bad it is because that doesn't make anyone feel good about their job. You need to know in this day and age exactly how your code behaves. So you should know how it performs architecturally and passing all your tests. You should track how this behavior changes both when you make changes to your code base but also when you don't. So because everything might seem really normal on one of your developers' PCs, and it might seem really normal the first couple of times that you run tests on it in your test environment. It might seem really normal the second or third or fourth or fifth time, But when you run your tests for like the 6th or 7th time, and things are drastically weird and you haven't made any changes, it's a pretty good indicator that something is going to go wrong in production for you at some point. So, back to the issue we were looking at with this client. The problem we isolate down to a very, very obscure bug in the way that we've implemented Hibernate and Spring. What's happening? Each call to the app runs a database statement to select the data that needs to be updated, which is what we expected. This method then passes the session over to another Hibernate call, which passes the session over to another Hibernate call, which is meant to update the data. What's happened here is that we are not passing the session correctly. We I'm assuming, just assumed that Hibernate would do that for us, and so the second method gets this request to update the database, goes, I don't actually have any contexts, goes and picks up the whole database table, loads it into memory on the JVM, and then starts reading through it line by line by line. Obviously, what's happening, that JVM is running out of memory, but it's okay because the AMQ process knows that. So the first JVM goes down, and then it starts sending requests to the next JVM on the next server. Obviously, we have no clustering, so eventually what they were getting to was a point where all 4 of the servers in production were basically at a standstill. They were all frantically trying to garbage collect because they had whole database tables loaded into memory and couldn't. So quickly, everything goes from being fantastic to being, I can't log in, I can't do anything. It's kind of a really good reminder if you're using frameworks in any of your applications, understanding how they actually work is quite important. There is so many times where we come across things where people have gone, I just use the standard SharePoint framework, or I just use this framework and it says that it'll be all right. And then you go, if you actually knew how like SharePoint had implemented that, you'd know that they're just reading like everything, and that's probably not the best way to build high-performing systems. So, in conclusion, we fixed the issue. It took a couple of days to get the fix put into production, but after that, everyone was really happy. The customer hadn't had a weekday in the last 2 weeks where the system hadn't either gone down for 2 hours because of a restart, or been so slow that they actually couldn't use it. So they were pretty ecstatic at this point. Our ops guys were pretty stoked. They'd never actually been able to see how the users were experiencing their site, so it gave them, having the tooling in there, gave them a whole lot more information about what they were doing and what they were trying to do, as opposed to just their Nagios dashboards. We ended up actually keeping the Dynatrace APM product in with this client because they had a whole lot of other issues that they were trying to fix. And the ops guys loved it. They were really stoked. The client was happy because they could actually see what was happening with the system, which was pretty cool. We ended up at the start of this year rolling more tooling out into all of their pre-prod environments, and we're looking at the moment at actually rolling out into our early internal dev and test environments as well, so we can start picking these things up much more proactively. Cool, I think that's the end of my presentation. Does anyone have any questions? I'm finished a little early, I think, which is good.
If we want to start playing with APM tools, are there any good open source ones we can start looking at?
I'm not sure about open source, sorry, because I work for a big corporate and we pay for stuff. But all of the APM tools on the market basically have either free trials where you can download and run forever for free in small instances, or they have like 30-day trials or 60-day trials or that sort of thing. They basically all have free trials. It's a very competitive market, so you can just jump from one to another and everything will be good.
You mentioned the team looked fairly frazzled when you sat with them at first.
Yeah.
How did they look now, and have they changed anything?
They're much less stressed now. We noticed after a couple of days of having stability, they stopped getting all the random guys in suits turning up anytime like a P1 or a P2 occurred, because what used to happen is they'd have a P1 And basically everyone who was even slightly involved in the system would stop what they were doing once they got the email and just frantically run down to the ops team. It's really hard to try and triage stuff when you have like the customer standing right behind you going, what's happening, what are you doing to fix it? So yeah, they're much more relaxed now and they can kind of think things through without freaking out so much, which is nice.
Why Dynatrace?
Question was why Dynatrace?
Yeah, fair enough. I told myself I wouldn't stand up here and talk about Dynatrace because I don't want to, because I don't want to bore you, but
Go on.
I went through, when we started doing this a couple of years ago, I went through like a full feature benefit analysis thing for most of the APM tools on the market to try and find out what was the best. And at the time, I was actually in an ops team and we supported basically 6 or 7 different applications, different technology types. We hadn't built them. We didn't really know what they do. We'd get lumped with something. They'd be like, oh, you support this now. Have a nice 3 years. And we picked Dynatrace basically because, like in this instance, I can turn up and deploy it and basically within 2 hours be telling people what's happening and what's wrong and that sort of thing. And that speed to getting things going is super important. Cool.
You mentioned that you got access to production and everything you needed. Did the developer that wrote the code originally have the same level of access?
I wouldn't know because the developer that wrote the code left after he just basically left the company after they delivered it into production the first time. It had been a project that had been running for about 3 years and they were on about version 3 and all of the developers and architects from version 1 had promptly left once they finished version 1, so yeah.
How do operations work closer with developers in your scenario?
Yeah, so we're pretty lucky. About the time that we started doing this, there was a big push from like our corporate management to be more integrated and less siloed. And so we ended up actually merging the dev and the ops teams into kind of one team. And everything's not perfect, unfortunately, but they kind of work together and we end up trying to pull a lot of the developers into production issues so that they kind of have an understanding of what the ops guys have to go through and what the impact is and all of that sort of stuff. But yeah, we're not perfect, so yeah.
So after this, is there any sort of post-mortem that you do between dev and ops, for example, saying, so not everyone has the option to install Dynatrace and I use it, so I know how good it is as well, but so is there any sort of process afterwards, I guess, is where the developers sort of build their own performance metrics into the application, the ops team updates in their DLS dashboards to actually show what what's going on in the...
Yeah. So I probably can't speak to that. I think every client we've gone into and done pieces of work like this have elected to keep the sort of tooling around because they see it and then they freak out and go, we'd have to retrofit all of our logging or basically rebuild our entire code base. And when you're looking at something that's often been around for like 5-10 years, they're going, cost of doing this is super high. Cost of having something there that's already in is not as big. So yeah, sorry, I can't really answer.
Thank you very much, Bridget. That was fantastic.
Sweet, thank you.